All right, so we're continuing chapter 8, 8.2. We'll be graphing still quadratic functions, but in this form, ax squared plus some number c. An example of that is y is equal to x squared plus 2. In this case, a is 1. That's whatever's in front of x squared. Since there's nothing in front of x squared, we can put a 1. B is actually 0. So b is the coefficient of x, or whatever's in front of x. There's no x term in this equation, and then c is actually 2. So we'll take a look by building a table at what the points are for y is equal to x squared plus 2. And as always, we'll compare that to y is equal to x squared, or the parent function. So I've created my table. Again, I selected the values of x, or the input, -3, -2, -1, 0, 1, 2, and 3. You can select whatever values you want. You should have some negative values like I do. 0 really should be in there. And then some positive values as well. Because if you only pick positive values, you wouldn't see exactly what the entire graph looks like. But the first input is -3. Okay, so I'll show my work for some of these, maybe not all, but it's x squared, so -3 in parentheses squared plus 2. -3 squared is -3 times -3. That's 9 plus 2. So when x is -3, y is 11. Then I could substitute in -2. -2 squared is 4, and then plus 2 is 6. Then input -1. Y equals -1 squared is 1, plus 2 is 3. 0 squared is 0, plus 2 is 2. 1 squared is 1, plus 2 is 3. 2 squared is 4, and then plus 2 is 6. 3 squared is 9, and then plus 2 is 11. And then I'm going to graph these on a graph in a second here. So I just transferred over the points that we came up with in the table onto this graph, and then I'm going to graph each of those points. I can go by or get by with going by ones on each of my axes. So one's on the x-axis and then one's on the y-axis. If you go by ones, you don't need to relabel certain things. But one of the points I have is -3, 11. That would be right here. -2, 6. -1, 3. 0, 2. 1, 3. 2, 6. And then 3, 11. Should be right here. So it's still a parabola. Again, everything that we're graphing in chapter 8, parabolas. So their curves would look like this. And then I'm going to graph y equals x squared. Remember, from 8.1, we came up with the table. We used the same x values, -3 to +3, 9, 4, 1, 0, 1. Oh, I forgot 2 here. 4, and then 9. So I can graph all those points, 0, 0, 1, 1, 2, 4, and then 3, 9 would be right there. And here's what the graph would look like. Let's actually get all the points graphed. Again, still a parabola. And the graph would look like that. So if I'm comparing y equals x squared plus 2 to y equals x squared, it's not any skinnier or wider. So there's actually no vertical stretch or vertical shrink. I'm going to scoot this up so I can have room to write certain things. But what happens with this graph compared to this graph? To start with the blue graph, to get the red graph, we're basically just shifting everything up. So if you remember what a shift up or down or right or left is, that's a translation. So to compare it to y equals x squared, there's a translation. 2 units up. And I know I didn't write it down, but I still want to figure out all the other parts, whether the graph opens up or down, where the vertex is, and where the axis of symmetry is. So again, I'm looking at the red graph. Opens up for sure, because the graph looks like this. It doesn't open upside down. Another thing is the vertex. Every single time so far, we've had the vertex at 0, 0. The vertex is definitely not at 0, 0 now. Ooh, shoot. Okay, sorry, I graphed that point incorrectly. That should be at 0, 2. So ignore this part right here. I graphed it at 0, 1. I have the point correct right here. It should be at 0, 2. So the vertex is at 0, 2. And then the last thing is the axis of symmetry. The axis of symmetry is still the y-axis, or the equation is x is equal to 0 for the graph of y equals x squared plus 2.